Hi students, welcome all. Today I am going to start our syllabus. Our subject name is Linear Algebra and Multivariable Calculus and the subject code is MAT 101 and the first module is Linear Algebra. Module 1 is Linear Algebra. It is all about matrices. We all know what is a matrix and what are the special type of matrices and determine how to find out the determinant of a matrix, how to find out the inverse of a matrix that you all studied in your previous classes and in bridge course also. Now I am simply moving on to our syllabus. First topic is rank of a matrix or first topic is rank of a matrix. Before going to the rank of the matrix, we have to study about the elementary transformation in matrices. Some elementary transformation, we have to study some elementary transformation that is useful to find the rank of a matrix. Okay, what are the elementary transformation in a matrix? Look at this. First one is interchanging any two rows or columns. That is Ri is interchanged to Rj or Ci is interchanging to Cj. This is the first elementary transformation. And the second one, multiply any row or column by a constant value. That is Ri gives k into Ri. We are multiplying any row or column with a constant element, So, or Ci gives k into Ci. And the last one is adding any two rows or columns. That is Ri gives Ri plus Rj or Ci gives Ci plus Cj. These are the three elementary transformation which is helpful to find out the rank of a matrix. Now, what are equivalent matrices? Text definition is equivalent matrices. Look at these two matrices are said to be equivalent if one can be obtained from the other by a sequence of elementary transformation. That is, when we are given a matrix A and we apply some elementary transformation in that matrix and after that we reduce the matrix to another matrix, another one where we get another matrix say B, then those two matrices are said to be equivalent and both the matrices are having same rank. Okay, both the matrices or equivalent matrices are having same rank. Okay, now I am going to another method, that is row reduced echelon form. The row reduced echelon form, and after that I will give the definition of rank of a matrix. Okay, so here I am saying equivalent matrices are of same rank. Okay, that you keep in mind. Now the next definition. Now the row reduced echelon form. A matrix is said to be of a row reduced echelon form. It is if it satisfies the following conditions. A matrix is said to be a row reduced echelon form if it satisfies the following conditions. First one, the leading element in each row is 1. In a matrix, the leading element in each row should be 1. Okay. The next one is the number of zeros before the leading element. Number of zeros before the leading element in each row is greater than the corresponding number of zeros of the preceding row. So, when coming downwards, the number of zeros increases. That is, the number of zeros before the leading element in each row is greater than the corresponding number of zeros in the preceding row. And the third point is, the row having zeros only are at the bottom of the matrix. The row having zeros only, that is 0 rows, are at the bottom of the matrix. Then, that matrix is said to be of row reduced echelon form. Okay, this matrix can be obtained from a matrix by elementary transformation. When a matrix is given, we use elementary transformation to make the matrix in the row reduced echelon form. And the first given matrix and the last obtained matrix are equivalent matrices. Okay, if A is a matrix given and we have to reduce it in the row reduced echelon form, so we use some elementary transformations for making it in the row reduced echelon form, satisfying these three conditions. And finally, we get a matrix and we named it as B. Then matrix A and matrix B are equivalent matrices. Okay, and equivalent matrices are having same rank. Equivalent matrices are of same rank. So, I am giving the rank of the matrix, definition of the rank of the matrix. Rank of the matrix is the number of non-zero rows in this equivalent matrix. the number of non-zero rows after this row reduced, after this elementary transformation we get a matrix in the row reduced echelon form. The number of non-zero rows in row reduced echelon form is the rank of the matrix. So the rank of the matrix is the number of non-zero rows. Okay, so this is an example for a row reduced echelon form matrix. Look at this, the leading element in each row is 1. The first row, first element is 1. Coming to the next row, the first element, that is the leading element is 1. Here the leading element is 1, then last row is 0. And the number of zeros, the second condition is number of zeros before the leading element is in each row is greater than the number of zeros in the preceding row. So this row doesn't contain any zero. Here there is 1 0. When coming to the third row, there is 2 0, that is greater than, this number of 0 is greater than, in the third row, number of zeros is greater than the second row. And coming to the fourth row, 4 zeros. So second condition is also satisfied. And what is the third condition? Third condition is the row having zeros only comes at the bottom of the matrix. Okay, at the bottom of the matrix, this row is 0 row, it is at the bottom of the matrix. So this is the row reduced echelon form matrix. So rank of a matrix is the number of non-zero rows in the row reduced echelon form matrix. Okay, thank you.